Yes, visible, sir. Yes.
Okay. So, so here you can see this is a syllabus which we will cover under this course of
Yes, yes, sir.
power
They shared
system.
this syllabus, sir. Yes.
Okay,
This one,
okay,
this one. Yeah.
okay. So this is the syllabus we going to cover. In this, you can see we have uh, everything related to protection and relay coordination. Okay.
Okay, sir.
So introduction to power system protection and then power system protection concept. Okay, what are the some basic concept? Okay, what are the protection philosophies? Okay, and then short circuit calculation, per unit calculation. Then we will see how to what is CTPT and their rules and their application in our protection. Then we will cover all sort of protection like ground fault protection calculation. Okay, and then relay setting coordination, how to do for relay setting coordination for overcurrent and earth fault. Okay, and then we see like if we talk about the protection of your distance protection, your transformer protection, your reactor protection, your busbar protection, your line protection. Okay, so all type of the whatever the main protection that we have, that we will cover. And what are the ancillary protection function associated with all these main protection? Like suppose if you are considering if there's a line, okay, or a feeder, so you need to take a line or feeder protection in which is the NSI code is 21. And then along with this main protection, you have other ancillary protection function like overcurrent, earth fault, under voltage, over voltage, jacksing, auto recloser, okay, SOTF, and CT supervision, CVT supervision, stop protection. So all these are protection which is associated with the main protection that we will going to cover. The same way in the bus bar protection, we have a different type of bus bar protection: high impedance, low impedance, centralized, decentralized. Correct. So all these of bus
Yes.
bar protection that we will see where we will use how to draw the schematics part as well. Okay. The same way for the trafo differential protection as well, like in transformer we have different type of protection: REF, standby earth fault, differential, directional overcurrent, and earth fault backup, which is backup protection. Correct. HV side
Yes,
REF,
sir.
LV side REF. So all these type of protection that we are going to cover, okay, in transformer protection. And we will learn each individual protection function, what is its role, okay, how we are going to adopt them in the schematics or in the transformer or in substation basically. What is their role and why we require them? What how they help us to achieve the protection philosophy and the protection in the system. Okay. The same way like selection of bus bar relay, we will see the selection of relays, how we do the selection of relays when you are doing the engineering. Okay, then it is all about to select the relay from the power system. Okay, so what are the different relays are available in the market and which is the best suited for your substation? Because most all the relays have the same type of function, same protection function. Okay, then what are the factor we are going to check to select the relays? Okay, and then we also see the setting of all these relays. How to do the setting of all these relay? Okay, so this is all we are going to cover, and then we will see like relay setting and coordination in your ETAP, okay, ETAP software, how to do the relay coordination, how to do the setting in the ETAP software, and how to put all these value, and then we after how to create the model in ETAP. After creating the model, how to put the all these setting in that ETAP model, and after that we need to check the sequence of operation. Okay, means from downstream to upstream, you need to after putting the setting value, you need to also check the sequence. Suppose in the downstream there is a fault happen in some breaker, some feeder, then it must trip the next, the immediate next circuit breaker if that circuit breaker fails. So it needs to give the trip command to the immediate next immediate circuit breaker, and then again if the next immediate circuit breaker fails, then it will, after some time delay, it will again automatically the next to next circuit breaker that is available, it will give the trip command to the upstream, the next upstream circuit breaker. So we will see all these things in our future classes. Okay.
Yes,
Apart
sir.
from this, there are substation automation system, or what we call SAS, or you can say the SCADA part of the substation. How we will draw the architecture, the SCADA architecture. Okay, what are the different components that are associated in it in this architecture system, SCADA architecture. So that we are going to see, and yeah, this is all we are going to cover in future classes. Apart from
Yes, sir.
this, if something is missing that you want and you think like it must also be in there, then you can tell me. Any other topic which you are willing to cover as per this syllabus or course. Is there anything that you want to know?
No, no, sir. No, sir.
Okay. Okay. So we will see all these topic from this. Prior to this, the first class that I will take of the busbar configuration. Okay. So in busbar
Okay.
configuration, we will see what are the different type of busbar scheme that are available in our power system. Okay, because that is the basic thing. You must know what is single busbar, what is double busbar, what is main and transfer busbar scheme, what is 1.5 breaker scheme, what is ring breaker scheme, and what is their advantage and disadvantage, at what voltage level you will consider all these busbar scheme. Correct. So for that, the busbar switching scheme is one of the main and basic things that we must know, because when you decide or create the protection philosophy, protection zone, okay, then all these things will be the basic knowledge of your busbar switching scheme must be required at that time. So for that reason, you must know all type of just a brief on that all type of busbar switching scheme that we are going to cover, okay, in first lecture. And yeah, and then we will also learn in that how to draw the SLD, single line
Yes, sir.
diagram. Okay,
Okay, sir.
so
Okay,
these
sir.
two concepts we will learn how to draw the single line diagram. Okay, because it will helps you to draw the KLD, key line diagram, or your protection SLD. Okay, so protection SLD, when you create, when you design the system, you need to give the protection in your substation or in your system, power system. Then how we will give all these protection in that we will see. Okay.
Okay. Yes, sir. Visible. Screen visible.
Okay.
Yes.
Okay. So here, what we will discuss about the basic concept about the busbar switching scheme. Okay. As we already know, we have a substation. Okay. So in substation, what we do the generation. Okay. The basic power system is all about the generation and distribute transmission and distributing the power. Within this topology or from generation to distribution, whatever the substation, connecting substation, distribution substation, whatever the substation that comes under this process, we do all the engineering of all this these things. Correct. So we have generation, then transmission, then distribution. So generation we do from 6 generally 5 kV to 16 kV. Okay, at lower voltage. And then the transmission we do at the higher voltage. Okay, we do the transmission at higher voltage just to save the to minimize the losses, to minimize the conductor size. Okay, so for these two main thing we do the power transmission at higher voltage, because when we do power transmission at higher voltage, what will happen? It will the efficiency or the losses will decrease. Okay, then this is like a general concept, like we generate the power and then the bulk power transmitted to various route. This is a very simple diagram which we have shown here. So in middle we have some large scale industry, and then we have some small scale industry. We have hospital, school. Okay, and malls. So for that, the large amount of power is required with respect to the residential, which is on single phase. Okay, so we these all industry and this small industry, all these customer require power at around 33 kV, 11 kV. Okay, on this voltage level, and the residence voltage is residential commercial, sorry, residential customer are on single phase supply, that is 220 volt. Now what is substation? Substation is nothing but we say a subsidiary station of electricity which comes in middle of generation, transmission and distribution system, where voltage is transferred from high to low or vice versa. Okay, in this the main thing which helps in this is the transformer. Okay, so transformer is a very critical and very reliable equipment in our power system. If it fails, then your complete substation, there is no, like there is no nothing that can work without your transformer. Okay. Now in this you can see we have a busbar strip R by B N. Okay, so this is simple house electrification, how we do, just for the example. So in our house we have some small distribution board in which suppose you in your house, in our house we have three-phase supply. So three-phase supply is coming. So first we will put MCB before entering the power. Just why we are putting this MCB? We are putting this MCB to protect our complete distribution board in case if outer side of this DB there are some unhealthy condition available. So that unhealthy condition will not enter into this distribution board. Okay, which can make our distribution board again unhealthy. So for that reason, we are putting MC. MCB full form is miniature circuit breaker. Circuit. This is a small mini form of circuit breaker. So that's why we added here miniature circuit breaker. The same way when the power is going to any other room or any big room, it will go through some MCB. Okay, so we have three phase, single phase, all type of MC. So this is a short example how we donate the how we do the house selectivity. In the same way, when the power is coming to your substation, we have one circuit breaker in each feeder, okay, which is helping in case of we have suppose fault outside that substation on that feeder, then we can trip that circuit breaker. So sorry, so that that the fault will not enter into your substation and it will not make your substation unhealthy. Okay, now this is a very simple example of here you can see a simple example of single bus bar scheme. So this is single bus bar scheme. In this single bus bar scheme you see, in this single bus bar scheme you see like uh, we have this three bay. We called this this feeder as a bay also. Okay, so we call this as a bay feeder. Okay, so we can call any of this thing feeder. Feeder, so this is a transmission line feeder, this is a in transmission line incomer feeder, this is transmission line feeder or bay, this transmission line feeder or bay, this is power transformer feeder or bay. So whatever you can call. Okay, then at the first place we put LA. Can you tell me what why we are putting this LA? What is the role of this LA?
To protect from the lightning strokes.
Yes, right. So suppose this line is coming somewhere from, suppose B is consider this is a substation B and this substation B. So this is line which is connected to the substation B and this is in this transmission line is present in outer area of the substation. Okay, and it is like 100 kilometers, suppose take an example. So 100 kilometer this is present in open area which is more prone to the lightning. So when lightning strike on this transmission line, which have the catastrophic event and which can destroy a complete substation. So this line, when it strike, it will break this and it will enter into your substation. Correct. So once it will enter into your substation, because the charge is so high, it can it can yeah, it can make burn or make any equipment unhealthy. Okay, because our all the equipments downside are uh, uh, sized for particular value, correct, for particular value, and this charge is very high in that in if you calculate, this charge is very high. So when it is strike, it enter into the substation, maybe our complete substation maybe became unhealthy, insulation burn or anything can happen. So for that reason we put lightning arrestor. Okay, also there's one other case, the over voltage. Okay, so due to some switching and something, the over voltage happened into our substation. Okay, and this over voltage, what we do, this over voltage can be grounded, which will not affect our complete downside equipment of that particular feeder or bay. Okay, so for that reason we have the LA at the first side. So that is why at the first point we put the LA. Then we have a CBT. Okay, then CBT is capacitor voltage transformer, or you voltage transformer you can say. So this capacitor voltage transformer or BT, what we have, we called it so this the purpose of this CBT and CVT is to measure the voltage, correct, to and the this voltage input will be provided to our relay. So for that reason we put this voltage transformer here. Now in this voltage transformer, the same way we have the current transformer, you can see here. So this current transformer dedicated to provide the current to the relay. So our relay will work basically on the input CT and BT input only. Correct. These are the two very basic input which we provide to the relay to function to properly to work this relay. Okay. So for that reason we provide CT and BT. Okay. And based on this CT and BT input like voltage and current, all other parameter will be derived, like power factor, okay, power angle, then your active power, reactive power, okay, that complete power, how much complete active plus reactive power, okay. So whatever the factor you need to derive, we can derive with the help of this voltage and input B and I value, okay. Now you can see here we have a wave trap. So the purpose of this voltage transformer is always to provide the voltage input to the relay. Now other thing is that we always the voltage is a voltage transformer always will connected in the parallel, because we are calculating the voltage of a point, okay. Now in this current transformer always comes in a series, so that's why it is present in series, because the current will flow from here, so it will measure across this, okay. Then here other term is capacitor voltage transformer. Capacitor voltage transformer, we are using capacitor voltage transformer. There are two reasons for this capacitor voltage transformer. First, we use capacitor voltage transformer when we have in our system PLCC, forte, like this communication. Okay, so for that reason, we provide this capacitor voltage. And this capacitor voltage transformer, we call this coupling capacitor. Okay, we call this capacitor present in voltage along with voltage transformer, we call coupling capacitor. Now these coupling capacitor will be the part of the forte and PLCC communication channel. Okay, so this forte and PLCC communication channel will be used at extra high voltage or EHV voltage. Okay, UHV or EHV. So you can say above 220 kV level. So whenever your substation is above to 20 kV level, in that case, you will provide this capacitor voltage. In that case, we require this forte and PLCC channel, or forte and PLCC communication channel. For that reason, we need to provide the capacitor voltage transformer. The other thing, the capacitor voltage transformer that fulfills is like, we know what is the ideal equation of transformer. So the ideal equation of transformer, if you remember, B1 upon B2 is equal to N1 upon N2 is equal to I2 upon
I1.
I2 upon I1.
I1.
Okay, so this is the ideal equation for the transformer ideal equation, correct? The same way, if you remember, like capacitor voltage divider rule. So capacitor voltage divider rule, if you remember, suppose if you want to measure the capacitance along the two capacitance, C1, C2, and this complete capacitance is C. This is B1, B2. How you calculate C1? So C1 will be given by voltage across C1 will be given by C2 upon C1 plus C2 voltage across complete B. Okay. So this is the formula. So you see the voltage across C1 is directly proportional to capacitance value of other capacitance. Same way here, what we will do here, the capacitor value we take in such a way that the C1 value is very very high with respect to the C2 value. So you can say C2 value, the capacitance value of second capacitor is negligible with respect to the C1. So what will happen? The size, the voltage across one capacitor, we will get very high, and across voltage on another capacitor is very low. And on the very low, the voltage across the capacitor on which the value of voltage is very low, we put voltage transformer primary connection. Okay, so how it helps? It helps, if you see, if you increase the voltage, the number of turns or the coil increasing. It means your size of the transformer is getting increased. Correct. Now, because it is 220 kV, 400 kV or such, like very high voltage, so the transformer size is very high. So to decrease the size, we give the capacitance value, one is very small, and with this we get the voltage across one of the capacitor is very low. So the primary voltage of your transformer is decreased from 220 kV to a very, very low level, because on secondary side we need only 110 volt, correct? On secondary side, the voltage transformer on the secondary side is always 110 volt all over the world. So the secondary side voltage is 110 volt, primary side voltage is 220 kV volt. So the size on the primary side of your transformer, or you say the particular transformer voltage transformer, is very, very long, very, very large. So to decrease the size, we do this, we do this capacitance divider rule to decrease the size of the transformer. With this, we decrease the size of the transformer, and we get the smaller size of the transformer. Did you get this?
Yes, sir. Yes, sir.
If you have any doubt, please ask. Okay.
Sir, this
Yeah. Mhm.
Forte, what is this one?
Yeah, this
PLCC, I know, sir. It is.
Forte is
Uh,
same like PLCC. Okay, Forte is like
okay,
advanced
okay.
version of PLCC. Forte is fiber optic telecommunication equipment. PLC is a power line carrier communication. Okay, so Forte here,
Yes, yes, yes,
we
yes.
use directly fiber optic cable for the connection across the
Okay, sir.
substation. For that purpose, we are using this communication. So for this, we need
Okay, sir.
like separate a channel, okay, which provide the connection, and then this Forte is connected directly to Forte channel is directly connected to your your relay. Okay,
Yes. Okay, sir.
and then we have a wave trap. So we know like PLCC works on very high frequency, correct? Like its value is from 50 kilohertz to 500 kilohertz. Okay, so but our power frequency is what, 50 hertz, correct? Now
Yes, sir.
if you see, all other equipment are designed for 50 hertz value only. So if higher frequency will go downside, okay, your equipment will not work correctly. So for that reason, we need some device which can filter this, band pass this frequency, higher frequency. So wave trap is a band pass filter which will allow only 50 hertz frequency to pass, and only allow what, only allow 50 hertz frequency, and it will block all other higher frequency which is required to operate this PLCC and Forte. Got it? So wave trap is our, we call simple, is a band pass filter. So for that reason, we need wave trap. Now you see why we are connecting these all equipment. LA first, obviously. We cannot put this wave trap here or there. The purpose will not define. The same way CBT will not put downside. The purpose will not define. So this is thing why we need to put the wave trap in this. Then we have a current transformer, as I told you, CT. Then we have earth switch. Okay, the earth switch is basically to discharge, sorry, the earth switch is basically to provide the discharge, whatever the residual charge that is present in your system, okay, to discharge the residual charge to the earth. Suppose if you want to do some maintenance on this location, so for that reason, what you will do, you will provide the connection to earth, and whatever the residual charge that is present here, you can discharge it, and a person can easily work on this part. So earth switch will be decided based on the like whatever the part that you have in your system, you want to, when you disconnect all the part from the system, okay, I mean to say, when you make all the switches including the circuit breaker NO, then whatever the tiny part that will be created in your system, for each reason you need to provide a single earth switch, so that if someone want to do any maintenance work on that particular part, easily the charge can be discharged to the earth. Okay, then we have this isolator. So isolator, simply we called it NO switch, okay, which help us to isolate the two different part from the system. So for that reason, we provide the isolator. Then we have a circuit breaker. So circuit breaker is, as already we know, like we used to trip whenever there is an unhealthy condition in the system, we used to trip the system. Then isolator. So this is how we provide the equipment in the system. and the same way we will provide the connection of all the equipment into the other feeder as well. Then we have the bus potential transformer for the bus, okay, to measure the complete voltage of the complete voltage of your bus, and then we connect it with with isolator. Okay, so this is how we create this complete SLD. Okay, now if you see, if I will show you some SLD which I have opened, where it is gone. कहाँ चली गई ये SLD भाई? So here you can see this is one of the SLD of 400 kV substation. Here we have provided two earth switch. So this earth switch is taking care of this part. Okay, this earth switch is taking care of this part. Okay, and this earth switch is taking care of this part, and this earth switch is taking care of complete this part. Got it? So for each region we have provided one earth switch. Getting it?
Yes, sir.
Okay, so that is why for each part a one earth switch is required. Okay, so in this way we provide earth switch for each and every part. So suppose if you trip this circuit breaker, this became NO. Okay, so this part, above part and above part will be a separate two different part. Then you open this isolator, then again this part will be separated, and this part became other, this also disconnected from the above, and this ground, this downside. So this part is standalone, one part, and this above part and this downside part. Okay, so that is why four earth switch is required. One earth switch, second earth switch for this region, third earth switch for this region if it is connected, this complete region if you see. Okay, and the other earth switch is for this region if you see, particular this region. Okay, and sorry, this it will come here, and other earth switch will be connected here, this one. Okay, so this is the reason why we are giving this earth switch. Got it? Now in this there are the philosophy that we are following for the nomenclature. Let me tell you the nomenclature how we follow. So this is how the nomenclature will be followed. Like first we do the voltage level. So we donate each numerical term with the voltage wise. If you 33, then 33 will use, 220 when 2 will use, 400 kV when 4 will use. 01 is bay number, then dash hyphen you, or dash, not a hyphen, dash. Then NSI code of equipment 5289. Then we use alphabet to donate basically to decide on which side it is connected, like A for bus 1, bus 2, L for line trafo, and E for earth switch. Okay, so here you can see, like we have this 221 11th bay, because this is 220 kb bay, so the 2 we use, then 11, then dash, and then LA. For here you can say 211 dash 89 is isolator. Sorry, EB we use because it is same, it is the part of isolator. So 89 LE. L, why? Because it is a 89 L part. Okay, so it is a earth switch 2 and earth switch 1. Okay, so for that reason, this is how we do the nomenclature. Same way here in 33 kb, you can see we have put it this there. Okay, got it?
Yes, sir.
Any doubt in this?
No, no, sir.
Okay. Then we have this, you see, single bus bar scheme. Okay, in this single bus bar scheme, if you see, so it is same like the all the feeders will be same like this. Okay, now you consider like our complete system is in a healthy condition. Now suppose there is a fault happen in this feeder. Okay, so your circuit breaker will get trip and this feeder supply will be interrupted, but rest of the feeder are in healthy condition. Correct. Now if we take the when we clear the fault, it will correct it, and then the system is again healthy. And then we have the fault on the bus again. Okay, it means when fault on a bus, all the feeder will get interrupted because this fault will be feed to every feeder. So this all circuit breaker will get tripped. So in this way, you can see when we in a single bus bar scheme, when there is a fault happen, your complete supply of your substation will be interrupted. It will become the blackout. When you clear the fault, again you can make it healthy. So what is the advantage, disadvantage of this? Like you can use single bus bar up to 33 kb. It is lowest cost, small land area required, easily expandable, simple in concept and operation. Disadvantage like lowest reliability, failure of a circuit breaker causes loss of a feeder, bus fault causes loss of the entire substation, which we have seen here. Now, what improvement can we make? We can like loss of the entire substation in case of a bus fault. So we will take care of this. This we need a solution for this thing. So what we provide the sectionalizer. So in sectionalizer, this is again the same system. Now you see there's a fault happen on this. Again, complete system will fail. The feeder will gone, and then we when there's a fault on bus, we divide this complete system substation in two part, section 1 and section 2. Okay, then what will happen, we provide one bus sectionalized circuit breaker here, so it will help us to segregate the substation two part, and when there is a fault, it will trip all these three circuit breaker and other part will remain in healthy condition. Okay, so this is how we do here, and when we clear the fault, again it will be kept. Okay, so this sectionalizer busbar scheme we use up to 66 kb, flexible operation, higher reliability than single bus bar, isolation of a bus section for maintenance, loss of only one part of a substation for bus fault. So these are the some example, like this have a higher reliability with comparison to single bus, because in when you have a fault on bus bar, uh, a small part of your substation are interrupted. Then isolation of a section for maintenance you can put. Okay, then loss of a circuit for circuit figure, a sectionalized bus arrangement has a higher cost, because a higher cost with respect to single bus bar, because here we have added a bus sectionalized circuit breaker and isolator and their engineering cost, land requirement, and many things. Okay, so for that reason, so here we can do improvement in this, like circuit breaker failure more than bus fault. So as per like case study, it is found that circuit breaker failure more than bus fault. Bus fault generally found 3%. Okay, and circuit breaker failure more than that. So we need to provide something like we need to provide a solution in which like we can counter this thing. So for that reason, we have main and transfer bus bar scheme. Okay. Now in this main and transfer bus bar scheme, if you see, this is again the same like that one. Okay. When you have a fault on this bus, it is again interrupted. Now you will bypass this circuit breaker through this isolator. Here you can see. Okay. So this is main and transfer bus bar scheme, because each circuit breaker required one circuit, each feeder require one circuit breaker. So for this, right now for this case, this bus coupler circuit breaker act as a feeder circuit breaker. So we need to do logic in schematics, and we need to create a logic in such a way that when you are transferring this feeder into the bypassing through this isolator, automatically the bus coupler circuit breaker became the line circuit breaker. Okay, then the same way here. So at a time we can transfer only one feeder, because why? Because a one circuit breaker is only required. When there is a bus fault happen, what will happen? Again there is a complete interruption of the supply. Okay, then it is again a problem for the substation. So this is how we do the main and transfer bus bar scheme. Okay, now here the advantages are like we can use this up to 132 kV, reasonable in cost, very small land area, circuit breaker out engine does not disrupt the service feeder. Bus fault causes disruption of service for entire substation. As we have seen, additional circuit breaker is required for bus time, which increase the cost. So in this, what we do, we need a like bus fault in a substation having more number of circuit cause greater interruption of a power. So for this, we need to provide a solution. We have double main bus bar arrangement. Okay.